Hello students, last class we have discussed the chemical properties of aldehydes up to named or special reactions, that is aldol condensation and cross-aldol condensation. The last set of reactions are reduction reactions. Here you will be studying two named reduction reactions. The first one is called as Wolff-Kishner reduction, and the second one is called as Clemens reduction. Now let us look to the details of the first reduction reaction, Wolff-Kishner reduction reaction. In this particular reaction, the carbonyl group CO group, this is the carbonyl group CO group, will be reduced to a methylene group CH2. CO becomes CH2 in the product. Let us see how it happens. Now here the aldehyde is treated with hydrazine. I hope you all know hydrazine. The formula is NH2 single bond NH2 or N2H4. This reagent we have come across in the set of condensation reactions. So aldehydes react with hydrazine. NH2 single bond NH2 is hydrazine. Yes. So here elimination of H2 and O as indicated there. Elimination of water H2 and O, you will get the product as RCH double bond N NH2, which is nothing but a hydrazone with the elimination of H2O. Now this hydrazone which is formed will further react with alkali on heating. The alkali used is potassium hydroxide in the presence of a high boiling solvent. The example for a high boiling solvent is ethylene glycol, which is a dihydric alcohol, the structure of which I have explained in the topic alcohols. So here the product obtained will be a hydrocarbon. CO is converted to CH2. There in the product you can see RCH2H, which is nothing but RCH3 with the elimination of En2. So here if you can look, this N2 is eliminated and what remains will be RCH2 and H. That is nothing but a hydrocarbon which is formed here. So this is nothing but Wolff-Kishner reduction. To give one particular example, I will take acetaldehyde. CH3CHO is acetaldehyde. Acetaldehyde reacts with hydrazine NH2 single bond NH2. There is elimination of O and H2 as water, and you will get the corresponding hydrazone minus H2 is indicated there on the arrow. You will get CH3CH double bond N single bond NH2, which is nothing but acetaldehyde hydrazone. Now this acetaldehyde hydrazone on heating with the alkali potassium hydroxide, or even you can use sodium hydroxide, in the presence of high boiling solvent like ethylene glycol, N2 is eliminated. Just look here, if N2 is removed from here, this group becomes CH3, H2, and here it is CH. So that you will end up with the product as C2H6, which is nothing but the hydrocarbon or the alkane ethane with the elimination of En2. CH3 single bond CH3 plus En2. So this is an example for Wolff-Kishner reduction. Another named reduction reaction is called as Clemens reduction. It is called as Clemens reduction. Now in case of Clemens reduction, once again the carbonyl group of aldehyde CO is reduced to CH2. Now here this reduction is carried out by using the reducing agent as zinc amalgam in concentrated HCl. Remember, whenever Hg, mercury, is present with metal, it is called as amalgam. ZnHg indicates zinc amalgam in concentrated HCl. Reaction between ZnHg and HCl will liberate nascent hydrogen, which is indicated here. So hydrogen written in the square brackets is nothing but nascent hydrogen. Now this nascent hydrogen will replace oxygen of the aldehyde RCHO and converts carbonyl group into a methylene group, and in the product you will get RCH3, once again hydrocarbon with the elimination of a water molecule. Now to explain Clemens reduction, an example taken here is that of acetaldehyde, once again CH3CHO. Acetaldehyde on reduction, to balance it is 4H here, with zinc amalgam and concentrated HCl. CH2 group is obtained in place of CO, so that you will get the corresponding alkane. Ethane, once again the hydrocarbon CH3, single bond CH3, and the byproduct eliminated here is water. So this is Clemens reduction. So two named reduction reactions are mentioned for your syllabus. One is Wolff-Kishner reduction and the second one is called as Clemens reduction. So this is end of chemical properties of aldehydes. Now coming to the last part to know one or two uses of formaldehyde, aliphatic aldehyde, first member, which is a gas. Now very first use is in the form of formalin, which is nothing but 40% aqueous solution of formaldehyde. This is used for preserving the biological specimens. So it is used for preserving the biological specimens. Another use is in the preparation of the thermosetting polymer or thermosetting plastic bakelite. Now phenol formaldehyde polymer is nothing but bakelite. So one of the monomer in the preparation of bakelite is formaldehyde. Another important use is in tanning leather. That is one of the process used for cleaning leather. Tanning, the gas used is formaldehyde. Another very important use is in the preparation of a chemical compound called as urotropine, which is used as an urinary antiseptic in medicine. A very important use. When this urinary antiseptic urotropine is subjected to nitration, just remember students, nitration of urotropine will give you a compound called as cyclonite. Now this cyclonite is one of the component of RDX, which is used as an explosive. So urotropine is used in medicine, whereas cyclonite is used as an explosive. So these are the important uses of formaldehyde, which is an aliphatic aldehyde. Now coming to the aromatic aldehyde, benzaldehyde. As you all know, benzaldehyde has the odor of bitter almonds. Therefore, it is used as a flavoring agent wherever that flavor is required. It is used in the preparation of compounds like cinnamaldehyde, cinnamic acid, etc. So it is also used in perfume industry, and a very important use is in the preparation of a dye, DYE dye, organic coloring compound, malachite green. Malachite green is obtained from benzaldehyde, which is used as a dye, which is nothing but organic coloring compound. So these are the important uses of the aromatic aldehyde, benzaldehyde. So with this we will be completing the topic aldehydes. Now as I have already told, I have split aldehydes and ketones separately so that it becomes easier for your understanding. If you have revised aldehydes thoroughly, then ketones becomes very easy, because most of the methods of preparation and properties are similar to that of aldehydes. Now with this information, Let us move to ketones. As we have already defined ketones. Ketones are the organic compounds having the general formula RC double bond O R dash. So the general formula is RCO dash. Now where R and R dash can be either alkyl groups or aryl groups. Coming to the nomenclature. Yes, in the common system, the organic groups R and R dash are named first. After naming the groups R and R dash, the word ending added is a ketone. Whereas in the IUPAC system for the aliphatic aldehydes, the general IUPAC name given is alkanone. Now this name alkanone is obtained by replacing E of alkane. E of the corresponding alkane is replaced by the alphabets ONE. And you will be selecting the longest chain, parent chain with the carbonyl group. Number it such that the carbonyl carbon gets the lowest possible number. Let us look to a few examples. The first member CH3COCH3 having 3 carbon atoms here. So in the common system, the 2 alkyl groups are methyl groups. The prefix used is dimethyl. The ending is ketone. Now this dimethyl ketone also has a popular common name. It is called as acetone. So here it is dimethyl ketone or acetone. Now coming to its IUPAC name. In the IUPAC system, alkane, which is the alkane having 3 carbon atoms, it is propane. So here E of the alkane should be replaced by ONE so that it becomes propanone. Now where you replace E by ONE, there you should indicate the number or locant. The locant here is 2. Number is 2. So here you will be writing the IUPAC name as either propane 2-one, or you can write that locant before writing the alphabets. You can write it as 2-propanone. Both are correct. Either propane 2-one or 2-propanone. Coming to the next example. Yes, there are 2 alkyl groups. One is methyl CH3, the other is ethyl. In the common system, you should follow the alphabetical order. So therefore, E comes before M. Hence, you will be writing the common name as ethyl methyl ketone. The common name will be ethyl methyl ketone. Coming to the IUPAC name. Look there, the parent chain has 4 carbon atoms and the second carbon is the carbonyl carbon. Hence, it is butane 2-one or 2-butanone. Both are correct. The IUPAC name will be butane 2-one. Yes, this is butane 2-one. Now the next example, there are 2 ethyl groups on either side of the carbonyl group, CH3, CH2, C double bond O, CH2, CH3. So in the common system, it will be diethyl ketone. So 2 ethyl groups, diethyl ketone. Now coming to the IUPAC name of this particular compound, there are 5 carbon atoms in the parent chain and the third carbon is the carbonyl carbon. Hence it will be pentane 3-one or 3-pentanone. Both will be correct. Any one of the 2. Pentane 3-one or 3-pentanone. Next example, there are there is 1 methyl group and 1 isopropyl group. I hope you remember CH3 twice CH is isopropyl group. So common name will be following the alphabetical order methyl isopropyl ketone. So it is methyl isopropyl ketone following the alphabetical order in the common system. Now coming to the IUPAC system, just look to the numbering there. The third carbon has a methyl group and the second carbon is the carbonyl carbon. The prefix will be 3-methyl and IUPAC name will be 3-methyl butane 2-one. The IUPAC name is 3-methyl butane 2-one. Coming to the next example, wherein there are 2 isopropyl groups as you can see here. CH3, CH, CH3, C double bond O, CH, CH3, CH3. So the common name will be diisopropyl ketone. On either side of the carbonyl group, there are 2 isopropyl groups. Now coming to the IUPAC name. Second and fourth carbon, there are 2 methyl groups. So it will be 2,4-dimethyl as the prefix. And parent chain has 5 carbon atoms. Pentane 3-one. Just look to the IUPAC name there. 2,4-dimethyl pentane 3-one. So the IUPAC name is 2,4-dimethyl pentane 3-one. Yes. Now coming to an example of an aromatic ketone, which can be represented by the phenyl ring or the phenyl group C6H5. C6H5COCH3, which is an example for an aromatic ketone. Now this aromatic ketone has a popular common name accepted by IUPAC called as acetophenone. It is called as acetophenone, or you can also call it as phenyl methyl ketone. Sorry, methyl phenyl ketone, because alphabetical order should be followed. It will be methyl phenyl ketone in the common system. Whereas the popular common names are accepted by IUPAC, therefore it will be in the IUPAC system acetophenone once again, or it is also called as phenylethanone. Phenyl group is bonded. Here there are 2 carbon atoms. I'll just indicate. Yes, 1 and 2. Here it is carbonyl carbon. This is the phenyl group. So it is phenylethanone. Ethane is the alkane having 2 carbon atoms. Therefore, you can also call acetophenone or phenylethanone. This is regarding in detail about the nomenclature of ketones. Hope so you have understood the nomenclature of ketones. Now along with this class, I will be putting up the material as well as questions on the topic aldehydes. Kindly write the answers for the assignment questions on aldehyde, students. Next class I will continue with the methods of preparation of ketones. I will stop here. Thank you.